Hi, I'm going to discuss my solution to the LeetCode problem body strings. It is today's problem in the October LeetCoding challenge. I am Channa Bankapur from Go Master Technologies. So the problem definition is as follows. We have two strings A and B, which has just lowercase English letters. We need to figure out whether these two strings are body strings or not. And the definition of that is if we can swap two letters in A so that the result is equal to B, then we call them as body strings, right? So obviously those two letters are going to be of different indices, but they could be same letters also, just that the indices should be different. And we should always swap and then make it equal to B. So these examples are actually going to cover all those possible cases. So in the first example, which is very straightforward, you're going to swap A and B and you get B there. And in the second example, both A and B are already exactly same. So if you swap, there is only one way of swapping. You're going to get a different string. So that's why the answer is false here, right? And in the third case, even though the both strings A and B are same, it's okay. As in, we can still swap these two letters and we get the same result, and that is still okay. That's why the result is true here. All right. So this example is not covering any different case. Look at the last example. Both strings are of not same size. So in that case, obviously it's not going to be same, right? Because what we need is both strings has to be of the same size, so that if you swap two letters, you get the same length as B and also which is identical to B, right? So that's what we need. Okay, so let's look at the solution I have come up with. So here we need to swap two letters and then the whole thing should be equal to B, right? That means A can differ by only two characters with respect to B. If more than two characters are different, then we have a problem. And the number of characters that are different of two strings of the same length is what is called Hamming distance, right? So we are interested in finding Hamming distance here, and we are interested in only Hamming distance of 2. If it is more than 2, clearly it's not possible. If it is even 1 also, it is not possible because swapping is going to affect. And if it is 0, it is possible if there are two characters which are identical, like in this example of example 3, where we can just swap the same characters and still get B, right? So that's the idea. We need a Hamming distance of 2 or 0. 2 always works. Actually, yeah, not always works, because we should be having some letters, say X in one place and Y in one place. And in string B, we should have Y here and then X here, right? So the Hamming distance of 2 and those two characters are swapped. And if Hamming distance is 0, then we should have two characters which should appear, at least, which should be identical. That means at least one of the character duplicates, right? So that's what we want to find out. So Hamming distance is a very simple case. There are different kinds of edit distances. There is a video made by me. It's a dynamic programming solution for edit distance. Take a look towards the end. I just try to compare multiple distances, including Hamming distance. All right. So let's look at the solution here. So this is what I have done. It's a very simple solution. So I look at the sizes of A and B. If they're different, right away I can say the solution is going to be false. And then in this loop, I do the majority of the work here. So I also need to find say Hamming distance, but I'm not interested in a distance if it is greater than 2. I just need whether it is 2 or 0, right? So, and also if it is 2, I need to know the indices so that I can see whether swapping them is going to make it equal to string B. So I'm just now traversing over this one. This is the index I. So now look at this. If A of I equal to B of I, I'm not interested in. I'm going to skip it. So when they're different, that's when actually it matters to me. And when they're different, the Hamming distance is going to increase. And if Hamming distance has gone beyond 2, then I'm not interested. I'm going to break out of this loop. Otherwise, when they're equal, so right now Hamming distance is either 1 or 2. If Hamming distance is 1, that means that is the first one we are changing. So index 1 is going to be updated with I. If Hamming distance is 2, then index 2 is going to be updated, right? So these two things update once each, and then we come out of that. Right, when we come out of this one, all we need to check is the Hamming distance. If Hamming distance is 2 and index 1 of A should be as an A of index 1 and B of index 2 should be same, and A of index 2 and B of index 1 should be same, right? That's when the swapping is going to work, right? I don't have to compare the whole of A and B now because we already know it works, right? So otherwise, if Hamming distance is 0, we need to see if there are any duplicates. If there is at least a character appears twice, then we can say it is true. Otherwise, it is not possible. So these are the only two possibilities where we can return true. In the rest of the cases, it's going to be false. So how does this problem of finding whether there are any duplicates in a string A? Anyway, a string A is just lowercase English letters, right? There are only 26 possible English letters. So if there are more than 26 letters in A, obviously one of them has to repeat, right, by the pigeonhole principle. So I'm going to return true immediately there. Otherwise, I'm going to have more of a map here for every letter, those 26 letters. Uh, uh, Already seen kind of, aptly represents that. So I'm going to set it to false because I haven't seen any of those things. Now I just go over each character. If I have already seen the current character, what does it mean? This is the second time I'm seeing that. So it's a duplicate. So I'm going to return true. Otherwise, I'll set the already seen to true so that, if you see that once again, sometime later, we can return true. If that does not happen in the whole loop, then we're going to return false, right? See, this loop is not going to be too long because anything more than 26 is already taken care here. It's a loop which run at the max like 26 times, right? So that's how this should work. Let me submit it. Actually, it works pretty fast. Yeah. So I have seen the percentile values. It should work pretty fast, right? It's 97 percentile and it's good. All right. So it's a very simple problem, obviously easy problem, but yeah, highly recommended you should try to understand more of these distances, like edit distances. And there are more elegant algorithms like dynamic programming algorithms. Please go through them. All right. So like the video and subscribe to the channel, and make sure you put down your comments if you have any questions, suggestions, or anything to say. Thank you for watching. Keep coding.